Welcome back. So now we have some interesting word problems. Well, interesting being a relative term. So here we've got a tower that's located on the side of a mountain, and they say that is inclined 32 degrees to the horizontal. So that is measuring like flat ground, 32 degrees up. So flat ground, 32 degrees up. So there's our 32 degrees. A guy wire is to be attached to the top of the tower and anchored at a point 55 feet downhill from the base of the tower. Find the shortest length of wire needed. All right, so let's zoom in on this picture here. All right, so I know this wonky angle down here is 32. And then we're going to assume that a tower goes straight up and down. So I'm going to drop from G here. I'm going to make this a little right triangle in there. All right, so that means my little angle in here, I've got 32 and 90, so it'll be the leftover from that, which 90 minus 32, because if you 180 minus 90 is 90, 90 minus 32 is 58. So we got 58 degrees there. Now, when you're looking at this, it's like two lines intersecting, straight up and down line through the tower, and then the inclined line. So that 58 degrees we got there is also up here. Now, when I look at my wonky triangle, I know the 55 feet, I know the 125 feet. I don't have any way to figure out this angle at D or this angle at F, but knowing this is 58 degrees and that this is a straight line tells me that that is going to be 180 minus 58, which should be 122. So we have an angle and the two adjacent sides. They asked for the length of the wire, which is the third side. So this is law of cosines. We need to throw some labels on here. So, all right. I'm going to call that angle alpha. So our unknown side is A. Yeah, B and D sound the same. So this is B. F up here is gamma. So now our 55 feet is C. All right, so we just got to set up our law of cosines. We have what we labeled as alpha. Let me move that a bit. So I need the cosine alpha, so I got to start with the a squared. A squared equals b squared plus c squared minus 2, same two guys, b and c, cosine of the pair of the very beginning, alpha. All right, now we just got to fill in the stuff we know. All right, so b is 125 squared plus c is 55 squared minus 2 times 125 times 55 times the cosine of 122 degrees. That whole ugly thing is all something I can crunch, so let's go ahead and crunch it. Pull the handy dandy calculator back out. 125 squared plus 55 squared minus 2 times 125 times 55 times the cosine of 122. Yes, we're in degrees. Big number. Anything where I gotta write a comma is a big number in my book. All right. It's 25,000. But that's a squared. So if your gut was like, that's way too big, good. It should be saying that's way too big. Now I have 161.047. Did they give us rounding? No. But this is feet. So we need at least a little more than 161 feet. Now you could make some argument about like having to use part of it to secure it, so you might need a little bit more than that, but you need at least a little bit more than 161 feet. The real kicker here, though, was figuring out that 122 degrees. That seemed to be what tripped people up most last semester, was how do I take that picture and actually find the thing I need to use? Because it's not as simple as just plug the numbers in. Like the number 32 doesn't show up in our calculation because we used it to find the complement 58, and then we had to find the supplement at 58, so it was a little weird. All right, over here, I have a question from WebWork. So now we've got a point uphill, then we have this wire, and they want to know the length of wire. Now, WebWork, unlike our book, is very good at giving us rounding directions, because they have to. So I'm not going to solve this whole problem, but I'm going to help you guys see like where the pieces are. So our tower here, towers are straight up and down. We're going to drop that line all the way down. So I have here two lines that are intersecting. Not that color. That angle there is going to be equal to that angle there. If I have this measure, I have the two sides on either side. Can use law of cosines to find the third side. All right. The other one that threw people for a loop, assuming we still have it, is this one. So we have a regular, in this case, octagon, inscribed in a circle. Inscribed means it's inside, so the vertices of the figure are touching the circle, like we see in the picture, with a radius of 12 inches. Find the perimeter of the octagon. So I'm going to highlight perimeter here because that's the first mistake you can make, is I can find what one side is and type that number in, and all my calculations are correct, and I get it wrong because I'm not answering the question. The question was to find the perimeter. So that is all the sides. So this is going to be 8 times the side length. And if we look here, that's one of our sides. That's my really bad S. That's not much better. My 5s and my really rush 9s and my S's all kind of look alike, so I apologize, but it's an S. All right, well, they tell us the circle and they tell us the measure of the radius. And we have this shape inside the circle, so let's go ahead and guesstimate our center, right around there. And we want to draw in radiuses. Now, this kind of like begs the question, where do I draw the radius? So, strangely enough, in a different problem, it might make sense to draw that one that intersects the side there and it would actually bisect it. But in this one, since I want to know the side length, and I could figure it out from that, but if I draw in all of these, with my totally straight lines. All right, now we have a dreaded Ferris wheel. Yeah, I don't like the Ferris wheel problems either. Okay, not really. Let's say it's the top of an umbrella cord. There we go. Great. All right, but each of these segments, not all the way across, but from the center to the edge of the circle is 12 inches. So this is 12 inches, and this is 12 inches. So the question now is, can I find that angle measure in there? And this is where it can get a little weird, but this is why I drew all 8 of the radiuses in there. So it's hard to see what any one of these might be, but let me ask this. What are all of them? So all of them added together should be a familiar number, and there are 8 of them. So if you take that number divided by 8, that will give you that angle measure. Then you have side, angle, side. You can use law of cosines to find the third side. You could also use some right triangles and do some crazy trig calculations and also figure it out. It requires more effort than doing the law of cosines. And just remember at the end, you have to multiply that side length by 8 to get the whole perimeter. All right. So just touching on those. So hopefully y'all's homework isn't as crazy. Last bit's going to be Heron's formula, and I'll do one last video for that.